Hey everybody, Nicholas JMV here, and welcome to topic 1.3, estimating limit values from a graph. And today our objectives are three things. Number one, to understand that a graph can give you information about finding the limit of a function at a particular value. Number two, the concept of a limit also includes one-sided limits. And number three, a limit may not exist for some functions at particular values of x. So let's take those learning objectives and move a little forward and talk about the definition of a limit. And now this is going to be an informal definition. What a limit tells us, it gives us the language. It gives us the language of really how our output values, for describing how the outputs, so your function values, the outputs, the y values of a function behave as the inputs approach a particular value. So your inputs are your x values or your independent variable. So it gives us a language. And so really when we're talking about limits, we're looking at y values. And I want you to think about it. When you think about a limit or a speed limit, your function or the speed limit, you don't have to hit that speed limit. You're just approaching that limit. And that's what I want you to think about today. So below, there are three different functions shown below. Now they all look like the same line. So let's kind of look at them to answer the questions here in the box. So we have this straight line, and right away I noticed there's a hole here. There's a hole here, so that function is not going to be continuous. And so they ask us, the limit as x approaches 1 of our function is equal. Well, what's the limit? So as our x's are approaching 1, what are our outputs doing? What are our y values doing? So what I like to do is kind of draw an arrow here. I'm going towards 1 along my x, right? I'm getting closer. And even from this side, from both sides, I'm getting closer to the value of 1 here. And I see that my y value is approaching 3. So that's my limit as my function approaches 1. It's 3. Now below it asks me for the function value there. Here's the function value. Well, I already said there's a hole here. That function value doesn't exist there. There's a hole. So f of 1 here does not exist. There's a hole. Notice in this case that the limit exists, but the function value does not. Remember, a limit you can get really, really close to, but you don't have to touch that number or equal that number for your limit. So let's look at g of x here. And g of x looks like the same graph, and we're also approaching 1. So what's the limit as x approaches 1 of our function? So if I look from the right of that number, I look from the left of that number. So here's 1. And I'm approaching the y value, the output value of 3. And notice how there's still a hole in the graph, but there's a little bit different here. Something's different. I have this new point down here, right there. I've got a new point. That is g of 1, and g of 1 here equals 1. So in this example, g of x, the limit exists, and the function value exists. That was different than the first one. Notice how there's no point here. There's nothing here. So in the first one, the limit exists of f of x, but the function value does not. Here in g of x, the limit exists and the function value both exist. Now we get to h of x. H of x as x approaches 1. So we're going for 1 again. And again, that limit is approaching 3, right? That y value is approaching 3. And it just so happens now, different than the other two examples, f of x and g of x, h of x is filled in. H of 1 is also 3. Now I want you to pay attention to these three examples, because later on when we talk about when a function's continuous, these three functions set up nicely about what it means for a function to be continuous. And we're going to talk about that later, so hold on to these. So there are limits. So the little question down here, does the function need to be defined at a point in order for the limit to exist? And the answer, no. The function value does not need to exist. Okay? It doesn't need to exist. Remember, the limit is a function value that we are approaching. It doesn't say it has to be that function value. It's just the number that we are approaching. So let's talk about this idea. When does a limit exist? So from the examples above, a function value at a specific value of x does not have to exist for a limit to exist. This raises an important question. Here's that question. What must be true in order for a limit to exist? So let's look at the following example. So the limit of f as x approaches 3 from the left. So here is 3. Values that are left of 3. So what are numbers that are left of 3? Smaller than 3. 0, 1, and 2. So I'm going to be swinging down my graph like this from the left side, and I can see that my y value is approaching 1. So we approach 1 here. So the limit notation as x, remember, approaches 3 from the left at minus, that's not negative 3, that's from the left, is equal to 1. Now let's look at 3 from the right. So 3 from the right, numbers greater than 3, 4, 5, and 6. So I'm coming this way. And you can see the y value is approaching 3. So the limit as f of our function approaches 3 from the right side is 3. Okay? So that approaches 3. And then instead of a minus sign, we're going to have a plus sign. So if the two sides are different, if the limits, and notice how I'm going to put a 3 here now, you zoom in here, does not exist. So notice how the limit here for x, as x is approaching 3, does not exist. We have to think about the left and the right hand sides always. So when doesn't a limit exist? Well, a limit will fail to exist if the left side and the right side, or the left hand and the right hand limit, do not match. The left and the right hand limits have to equal at a point in order for the limit to exist at that point. Okay? And that goes back up to these 3 examples. In each one of these, the right hand and the left hand limits here, if I went back and did them again, the left and the right hand limits all equal the same value, therefore the limit at that point existed. Alright, so let's find some limits from this graph. So consider the graph of the function shown below. Use the graph to find each of the following. Okay? So let's go ahead and find those limits. The limit as x approaches 3. So if I look here at 3, and I can see from the right and from the left, I'm approaching the same number. That's 2. Okay. Then I go to the limit as x approaches 4, which is right here. I have a left-handed limit. Ooh, but I don't have a right-sided. So that does not exist. Oops. That does not exist. The limit at 4 does not exist. Only the left-hand limit exists there. So now the limit as x approaches 0, you see that plus sign? That's 0 from the right. So numbers that are greater than 0 are like 1, and 2, and 3. So if we're approaching 0 from the right, okay, there's 0. We're approaching it from the right here. Okay, that is 1. That's different than the one above. Notice how there's no left hand limit over there approaching 0, right? But see that plus sign? We want to know from the right. So the right hand limit existed. It's 1. Okay? So be very careful on that. It's a little bit different than this one. Here, when you're approaching a single number, you have to think about both left and right. But if you see a plus sign or a minus sign, you're only considering that one-sided limit. As x approaches 2, here is 2. We're approaching here and here. And that means our limit is also approaching 1. Again, here is 1 from the left. So let's look at 1 from the left. Here is 1. Let's clean this up a little bit so we can see. Here's 1. 1 from the left is coming down this way. And that looks like it's going to be 0. 1 from the right. Here's 1 from the right coming this way. Looks like we're approaching 1. And now you notice how these two limits, from 1 from the left and 1 from the right, do not match. That means the limit at 1 does not exist. The last little value here is f of 2. That is a function value. And f of 2, let's just do this in red, is right there. F of 2 is equal to 2. And so that's how we find that limit from a graph. We're going to go ahead and pause here because this video is going long enough. We're going to pick up on video 2 when we draw something to satisfy limit conditions. So if you have any questions or comments, please type them below, and we'll see you for video number 2.